Good day, my name is Christine Lu Qihuan. My selected tool for this COA group project is HWiNFO64. In this video, I will demonstrate how HWiNFO64 is used to monitor CPU sensor data during benchmark execution. I will also explain how the required COA performance metrics are obtained for workload A. For the analysis and discussion, I use the exporter HWiNFO64 CSV log as the main data source. Based on the results, the maximum total CPU usage is 100% and the average total CPU usage is 98.9%. This means the Sign-Batch CPU multiple threads benchmark successfully placed the processor under heavy multi-core workload. And the maximum core clock was 4987.8 MHz, while the minimum core clock was 399.0 MHz. This results a clock frequency delta of 4588.8 MHz and shows that the CPU dynamically changed its clock speed during the benchmark instead of running at one fixed frequency. So the maximum CPU package temperature reached 98 degrees Celsius and the thermal throttling was detected, which means the CPU became very hot during the 30-minute workload and reduced its performance to protect itself from overheating. So the CPU package power reached a maximum of 60.231 watts, showing that more power was required when multiple cores and threads were active. Therefore, the result shows a relationship between high CPU usage, high power consumption, temperature rise, and thermal throttling. Based on the exported HWiNFO64 CSV log, the maximum total CPU usage reached 56.9%, while the average total CPU usage is 16.6%. This is lower than workload A because workload B mainly stressed on one active CPU core instead of all CPU cores and threads. So for core utility, the highest value was recorded on P core 0 T1, which reached 195.7%, and the highest average core utility was also recorded on P core 0 T1 with 178.1%. This shows that P core 0 was the main active core during the single core benchmark. So dynamic train migration is analyzed by observing whether the active train moved from one core to another. Based on the CSV log, the workload mostly stayed on P core 0, while only brief activity was observed on other cores. Therefore, dynamic trace migration was observed only in a limited way. So for individual core temperature, P core 0 recorded the highest temperature, reaching 98 degrees Celsius, and the highest average core temperature was also on P core 0, which has the 93.7 degrees Celsius. The lowest average core temperature was P core 5 with 58.0 degrees Celsius. So since the temperature difference was 35.7 degrees Celsius, a localized terminal hotspot was observed on P core 0. This means that the heat was concentrated on the active core during the single core workload.